Hi, everybody. This is Dr. Schulman, and we're going to do 5B, which is the last video of the algebra series. It might be two videos, depending on if I run out of gas. But this is inequalities, but I also threw stuff on exponents in there too. I'm going to share my screen right away. There's some documents that'll help you out, some more practice. So if you want practice, if you go into modules, as you can see, the notes are already set up, no strategies for writing and solving linear equations and inequalities. So there's a ton here. There's a lot of stuff we're going to look at. But if we go to this last part of linear equation, oh, that's the quiz. I'm still toying with the quiz. But basically, I gave you these. So here's some slides for when you're working with one dimensions, just to help you out. If you need more information, this is an inequality one. Here's some problems to try. Obviously, I made this back in 2015, but it just has like some basic things to help you out. And some examples, closed versus open circles, compound inequality. So notice whenever it's this way, where it's compounded, it's always in the middle, right? Like S is greater than 14 and greater than 18. It's an open circle on S. So this is just something that you got to keep in mind throughout all the inequality stuff that you're going to be doing. So whenever you got it like this, well, this is open circle to closed. But anytime it's ever an equation where it's like this, it just means it's going to be in the middle, okay? While if you have a piece and another piece, it's going to go in other directions. And you'll see this a lot when we look at absolute value ones, things like that. But basically, whenever it has the word or, you're going to have two separate arms, right? We might have some extraneous solutions. When I say extraneous, that means when you plug it back in, it doesn't work. But for the main idea, when it looks like this, it's open. We've got dotted lines. And this is below. This is going to be above the line. And this is going to be below. So what do I mean by shading below? Shade it below the line. And if it's like this, it's greater than we're shading above the line. So that's the way that it's going to look like when you're working on it. Here's some practice problems to really help you out. Here, I'll do a couple of these. Just these on the bottom, just to give you a sense of how these work. I want pen. There's a pen. Cool. I said I'd just do the bottom ones. There's some more, which is cool. But basically, we want less than 6. So I can go to 6. It's going to be a closed circle. So I want to go this way, less than 6. And greater than -1. So -1's open circle in this way. So it's where it overlaps. That's this one. We want it greater than -2. So greater than -2 is everything this way. And less than 7. So 7's here and it's closed. But notice that it says or. And means it combines. You'll see this when we do probability. But if it's this one. It's everything. So whenever you have like this, you can do it's negative infinity to negative infinity. Or you can do this sign, which means it's all real numbers. That's for everybody. Oh, I forgot something. These have parentheses around the answers. So I should show you in set notation. So in set notation, this one is going to be -1, comma, 6 bracket. You can't touch infinity. We can just approach it. So that's the second one. These are set notations for the answers. This one is going to be in between. So it's going to be bigger than 0 and less than 5. So for this one, it's going to be bracket 0, comma 5 brackets. Here's the last one. We got to be bigger than 4, close circle, or less than 1, right? Less than 1, right? So here's 1. It's open circle. I'm going this way. Now, to draw this one, it's a little different. It has 2 parts, so I need 2 parts. So this is going to be, we always do this left to right like a book. The leftmost piece is negative infinity, and we stop at 1. Do we touch 1? No. Boom. Now it's or. So the end symbol, let me move my weird floating head. The end symbol, I was going to write in that little box. That's okay. So this means end. Looks like an A without the line through it, and this means or. So it's the union of this piece and this piece. So now we need the other part, which is, sorry, it's a bracket, because we actually hit the 4 to infinity. And that's a set notation for this one. Here's more problems you can look at. 8 less than 3 times a number greater than 15. 8 less than, here, 3 times a number is greater than 15. So this is A. Okay, cool. Just remember when you're doing this, if we're dividing by a negative, it's going to change. This is cool. If you plug it in and it doesn't work, it's what's called extraneous. So just keep that in mind. A lot of times with these, you have to plug them in to see. So you can try these if you like. What other ones did I have in here for you? I have a worksheet of just regular base inequalities. You can try them yourself. What's the good thing about these? Guess what? The answers are at the bottom. Isn't that nice? So we got the answers to these. And then we've got 1 and 2 dimensions. 2-dimensional ways of seeing them. And then notice the solution is going to be where they double, where they double, where they double. So these are good problems to try. Awesome. All right. Enough of that little intro. I hope that intro was helpful. If it wasn't, that's okay. The only other thing you really need to know, if it's a negative 8x is less than 16, when we divide by this negative 8, guess what happens to the sign? It's the only time the sign's going to flip. I've said this before, but I just wanted to show it to you. All right, so we're going to jump into delta. Here are the skills. There's a bunch, so I'll probably break somewhere halfway through, but let's just start with some basic inequalities. Nice. Select the numbers to make it true. Okay, so there's a ton of these. So we just need everything that's greater than or equal to -1. Is -9 bigger than -1? Nope. Is -2 bigger? Nope. Nope. This one's bigger, bigger. It's -6. Nope. Nope. Oh, that's end equal to. That works. So we just want everything to the what? The line points to where we want to go, and everything to the right of the line. So these are all to the right of the line. And that's the answer. Just everything from here moving forward, including that -1. This is a really good question. Feel free to try it yourself. But it's nice. Notice it's a closed circle going to the right. Right away, start with the hard one. I like it. Let's go level 2. All right, so now it's -7 is less, negative n is less than 7. We have to divide, we have to pretend there's a -1 here. So when we divide by -1, guess what happens? It's gonna flip. So we want everything to the right. Okay, that's what this means. We want everything to the right of -7. So -7's here. We want everything bigger. So this is everything bigger. It doesn't include -7. So we want everything to the right of it. And these are all the answers. Ta-da! What's another way we can write it? It would be parenthesis, -7, comma, infinity, parenthesis. N is greater than -7. All right, let's try a harder one. We'll go even harder. Ta-da! Everything's correct. Looks beautiful. All right, so here we go, even harder. Okay, so I have k over -4. See, as long as I'm multiplying or dividing by a negative, this sign is going to flip-flop. When I multiply the -4, this means k is greater than or equal to a what? A -28. That's a lot. What's bigger than -28? Boom, 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 boom. Greater than or equal to -28. And just so we have it, the set notation would be it is bigger than it. So it's -28 to what? Infinity. Notice it's got the bracket there. So hopefully those were good ways to see. As long as you keep this on this, I try to keep this on the left as much as possible so it points to where I want it to go on the equation. All right, let's try a true or false. Ooh, we get to try some of these. That is true. That is true. That is true. No falsies? That is true. That is false. That is true. That is false. The alligator always wants to eat the bigger number. What? Oh, I meant false. The good thing you can show your students is you draw a little alligator on the slide, and he always wants to eat the bigger number. So, all right, I got to start again. This is true. This is true. This is false. This is false. This is true. This is false. This is false. This is true. This is true. This is true. We did it. Cool. So we got our 10 out of 10. Try practicing with this. It'll be a good way. All right, here's another practice. Which one is it? It's open circle, and it's everything greater than -7. It's open circle, and it's everything greater than -3. It's closed circle, and it's everything less than 7. It is open circle, everything less than -3. It is closed circle, everything less than -10. So it's going to be less than -10 and closed. It is closed circle, and we want everything bigger. So everything bigger is to the right, and it's closed. Notice it just points to where you want it to go. Open circle left, open circle left, open circle left. So we want -5 this way, and it's open circle. Open circle right. So we want -4 going this way, but it's open. And then it's closed going this way, everything greater than or equal to 8. Cool. So here we go. Try some of these. They'll be fun to do. All right, let's see what we got for this one. Which of the following values solve it? So does 14 work? Does 4 work? Does -2 work? I always just solve it. That's just me, but everybody does these different ways. So -5 plus 2x is greater than or equal to 6. I'm going to add 5 to both sides. 2x is less than or equal to 11. I'm going to divide by 2. X has to be less than or equal to 5.5. 14 is not less than it, so it can't be 1. 4 is less, -2 is less, so it's 2 and 3. That's how I always solve it. Ta-da! Oh, they plugged them in. All right, let's try harder. So which is true when d is equal to -11? Okay, so we have -11. These I gotta plug in because it looks weird. So it's a -11, so plus 11 minus 9.5 is greater than or equal to, no, not the first one. So it's a -11 minus 9.5 is less than or equal to -9. Well, this is a -20 point, sorry, a negative, yeah, 20.5 is, it's this one, it's the second one. Wild. So we got it. It was just the second one we needed to try. Oh, I like the little number here, number line, but it looks good to me. We got the same thing that they did. All right, let's keep on going. So here we go. We get to draw it ourselves. We get to solve and draw. That's usually what you have to do. -7 plus 8x is less than or equal to -23. We're going to add 7. -23 plus 7 is, I believe it is 16. A -16, this is 8x. Now, even though I'm dividing by 8, this is a negative. This is negative. I don't care. I don't care. This one, it just has to be near, as long as there's a negative near the x, then would flop, but it's not. So x is less than or equal to -2. So we have x, I said x is less than or equal to a -2. We have to have it on the number line. Click and drag. Okay, so -2 this way. And it's equal to. If it was not equal to, I would have to open it. But because it's closed, boom. And how would you rewrite this? Be from -infinity to -2 bracket. Because it actually stops there. So definitely work with these, practice. All right, I'm assuming it gets harder. Yes, it does. All right, so let's keep going. So already, because there's a negative here, I feel like the sign's gonna flip. The first thing I'm gonna do is I'm gonna subtract 7 from both sides. That's negative 21, and this is negative 7x. I divide by negative 7 on both sides. This is gonna flip, and this is a positive 3. So this means x is less than or equal to 3. So I need a closed circle on positive 3, and I need to go this way. And this would be if it was not, and this one's going to be negative infinity to 3 brackets. That's how you do a level 2 problem of this. What? But I wrote flip it and I forgot to flip it. Oh, isn't that annoying? Okay, well, we got to do another one. I said flip and I forgot to flip it. So let's do it again. So 2 minus 2x is greater than negative 10. We subtract 2. Negative 2x is greater than negative 12. Divide by negative 2. Now I'm not just going to say it flips. I'm actually going to flip it. And so it's going to be less than 6. And this is going to be from negative infinity to 6 parentheses. So x is less than 6. And open it up. Ta-da! All right, so now we do some linear inequalities, level 1. Let's see what we have. Cool. Let's solve some of them. Here that we just solve. It's nothing too crazy. I'm assuming the next one's going to be nice and tough. Well, 0 of anything just falls. We don't need it there. So we're going to subtract 6 from both sides. That makes it negative t is less than or equal to negative 2. When we divide by this negative 1, what's going to happen? The sign is going to flip. So t is greater than 2, so it's going to be from 2 to infinity. So t is greater than or equal to a positive 2. I should be checking them all, but you can check them yourself. You're like, ta-da, we got it. All right, let's step it up to a level 2 problem. 1 minus 5 negative 9m plus 6 is less than, I'm going to need some more space for this guy, negative 3m minus 2 minus 4. So the first thing I'm going to do, remember this whole minus has to come with it. So it's going to be a positive 45m, and it's a negative 30. This, we can put these together, negative 3m minus 6. 1 and a negative 30, so I have 45m minus 29 is less than negative 3m minus 6. Always leave this on this side. So I have 48m minus 29 is less than negative 6. I'm going to add 29. So it's 6 plus 29 is going to be a 35. Wait, what? It was a minus and I added it. So I'm a liar. It's going to be a positive 23. My bad. So we divide them both by 48. The sign's not going to change. Get out of here. Oh, and I don't think we can simplify that. I think it's just going to be 23 over 48. So, oh, it's right how we like it. Let's see if I did all that right. I could have made a mistake somewhere. We did it all correctly. And this is how it should look. It should look, since it's going to be less than, negative infinity to 23 over 48. This is called the set notation. Oh, sorry, I'm a big liar. This is your interval. There's your set. That's your set notation. So your set would be m. There we go. Having notation is good. All right. Now we got one with a fraction. Cool. It looks tough, so let's do it. So negative 6x is less than or equal to negative 7, negative x over plus 2/5 plus x. So let's see if we can solve this guy. We got a negative 6x. We got to bring the minus to both. So that's going to be a positive 7x. We got to bring this over here. 7 times 2 is 14. So it's going to be negative 14 over 5 plus x. 7x and an x makes that an 8x minus 14 over 5 minus the 8x to both sides. I've got a negative 14x, negative 14 over 5. Now we can't forget when we're going to be dividing by, it doesn't matter how we do it. We're just going to divide both sides by negative 14. So we're going to multiply by 1 over negative 14. They're going to cancel, and this sign is going to flip. A lot is happening. Because this is the same thing as multiplying by 1 over negative 14. There we go. Those cancel. So I believe it's going to be a positive 1/5. That was a lot. Let's see if that's right. Wild problem. Let's see what we got. So crazy, right? Wasn't that crazy? Felt crazy. All right, so let's do another one. State all alternative values of x in the interval -6, 1 that would satisfy. So an integer, remember, they're whole numbers. So we have -6, -5, -4, -3, -2, -1, 0, and 1. Ta-da. So we just have to see which ones will make this work. I like just solving it and seeing. So I'm going to add the 10. Now we're dividing by negative, so this is going to flip. So x is greater than -13/3. Now, if that, oh, sorry, it's less than -13/3. You don't know what it is. Let me move my head. There we go. 13 divided by 3. All right, it's 4.3333. So x -4.3. Which ones are less than that? 5 and 6. That's what it is. -6 works, and -5 works. We could have more, but that's all that works for this guy. Beautiful. I love the picture. Now let's do one. We did a fraction. Let's go decimal. Same idea. 1 is greater than or equal to 7x minus a minus 2.1x minus 8.1. Wild. First thing I'm going to do is I'm going to distribute that business. 1, 7x plus 2.1x minus 8.1. So 1, 9.1x, I combine them, minus 8.1. Then I'm going to do some moves. I want, well, I'll show you a different way to do it. Plus 8.1 plus 8.1. 1 plus 8.1 is 9.1 is less than or equal to 9.1x. When I divide by 9.1, I'm left with x is less than or equal to 1. Now, we don't like it here because it's hard to do. So if I do this, I can flop it. So here's what it would look like. We know it's from -infinity to 1, parenthesis, bracket. This would be everything. This does not exist. For some reason, we were left with like 2 is equal to 3 at the end. Would be like, no solution. Does not exist. That might happen sometimes, okay? But we have an answer. It's x is less than or equal to positive 1. Whoa! I lost my negative sign? Are you serious? Where's my negative sign? Where'd I lose it? Oh, right here. A negative times a negative is a positive. That was the one mistake. That's the good thing about math, right? You can see the little spots you mess up, and then you're good to go. All right, so here we go again. I forgot a negative sign, but guess what? We're all human here, right? A negative, negative. Oh, I'm just going to redo the entire problem. Okay, 8x is greater than or equal to negative 3x plus 6.1 plus 10. All right, so the first thing I'm going to do, this has to go to both. 8x is greater than or equal to 3x minus 6.1 plus 10. I'm going to minus 3x to both sides, so that's 5x. And this is going to be 10 and negative 6.1 together. I believe that's got to be 3.9. I don't want to make any more mistakes. It's just 3.9 divided by 5, and we have our final answer, which is 0.78. X is greater than or equal to 0.78. Yeah. Sweet. Try some of these. Have fun with it, you know. Do what you can do. And finally, we're up to the compounds. So let's do some two at once. Compound is where stuff gets tricky. So we have to do both of these. 6x plus 9 is less than negative 16. Or, and you can use the union button, 34 is less than or equal to 5x plus 9. The first one, I'm going to subtract the 9. That's a negative 25 is 5x. Don't worry, the negative's not here. The sign's not going to flip. X is less than negative 5. On this side, we're going to subtract the 9. We have 25, 5x, divide by 5, x, 5. I want it the other way though. X, flip it, 5. So these are the two. We can do x is less than negative 5, or x is greater than or equal to positive 5. And so we need it to be negative 5 going this way, but we want it open. I want positive 5 going this way and keep it closed. And that's the whole kit and caboodle. Ours looks just like theirs. Theirs is just way neater. But let's do a hard one. Cool. I knew it would happen. All right, so I'm assuming this one's going to be all solution or no solution, something like that. But let's solve it. 4x plus 9 is 37. Union. All right, so here's your first step. We're going to minus 9 to both sides. That's going to be 26 divided by 4. What is that, 7.5? I think it's 7.5. 6.5. We all make mistakes. Oh, let's do the other side, minus 9. Is that a 57 over there hiding? Yep. That's going to be 48. And this is x is less than or equal to 12. Notice that these are the same way, right? This means one's going to supersede the other. What am I trying to say? So if I have 12, right, and I want less than or equal to this, notice that the 6.5 is right there too. So all I need to write is this one. Do not write the other one. If it was everything, could have been all real, could have been no solution, but guess what? It's just going to be x is less than or equal to 12. Really try these. These are the tough ones. These compound ones are tough. So it's just 12, the whole thing. Really try some of these. Nice. But now let's go at absolute value. Cool. So this is the keep it, switch. So I know it's the absolute value of x minus 4. Because this is already by itself, it's isolated. There's no like +2 outside or +3. As long as the bars are alone, we can split them. The first one, we're going to keep it. The next one, I'm gonna switch the sign, the inequality and the symbol. So it's the symbol and the sign. Symbol and sign get swapped. We're gonna add 4 to both sides. X is less than 11, and this other side, we're gonna add 4. X is greater than -3. So we know it's gonna be X. Well, we want the whole thing, right? Because this is both together. So this is how this one's gonna look. -3, X, 11. See how I did it that way? And this one's gonna be -3 to 11 because it's not two separate pieces, they're combined. So this is an and happening, not an or. Come on. I gotta redo it. Might as well copy. I'm ready for a level 2 of this. Oh, I didn't give you a level 2 of this, which is fine. You got enough problems to try. And we just did the absolute value one. So up to combining like terms. So nice and easy stuff. So let's drag and connect some of these guys. These go together. Oh, sorry, one's X and one's Y. These go together. Uh, these go together. These go together. We combine them all. So you just put whatever is raised the same thing together. They also have to be the same letter. All right, let's do another one. I always start with the biggest. So a negative, oh, so 5 plus 3 is 8, minus 1 is 7. The next one's going to be my x term. So negative x and positive x fall away, so no x's. -1 and -1 is -2. That's it. That's the whole thing. This is called a cubic binomial. It looks like this, just so you know. It's going to be a positive x cubed cubic binomial. All right, well, computer is lagging, but that's okay. We did it. Right? So we're up to exponents. So to expand this, we're just going to have to multiply. I've got 4 x's. Then we have 4 y's. And we have 2 z's. Put them together, we got it. So I threw some exponents in here just to practice. This is a mistake that happens all the time. Remember that this goes to this one. There's nothing here, so it lives there. But there's like, this is like 1 times 2. This is like 1 times 1, right? So this is just squared and 2. So the exponents on the variables just kind of go there. If there was a 3 here, it'd be squared, but that's all this one is. Oh, we got to do the expand too. All right, 4 times 4 times x times x times z times z. That was pretty good. So 16x, sorry, x squared, z squared. Sweet. So, but if it was like this, right? If it was like 3x squared y to the third, I'm raising this to the third power, 3 to the third power, that's 27. There's someone in the way, so it's x to the sixth. There's someone in the way, y to the ninth. I said ninth. Yelling at my hand. All right, let's do some exponent rules. Multiplying is adding, so this is x to the seventh. Try as many of these as you like, just to get some practice with it, you know. Now I got one of these. Oh, it's just like the one I just did. So similar. So this is negative 27. X, 2 times 3 is 6. It's almost the exact same problem I wrote over here. Isn't that wild? Great minds. Beautiful. Let's do some distributive property stuff. So we have 4x negative 1 minus x. So this is going to be a negative 4x. This is a negative 4x squared. Interesting problem. Interesting. Practice with your distributing. Make sure it goes to both. You should be good to go. Beautiful. Whoa, wild. Gotta love the graphics. Gotta love the graphics. Let's do one that's real. So this is a negative 56. I don't know why my brain doesn't want a brain. Okay. Negative 56 x squared and negative 40. Cool. Now let's multiply some powers. All right. There's a lot here. 10 and negative 13, that's negative 130. X to the third and x squared, that means we have x to the fifth power. Y to the third and y to the third is y to the sixth power. This will help you a lot. Help students, if they want to know why this works, you can show them like how it builds to their understanding for crazy things like logarithms and stuff like that, which will be cool. All right, now we're raising powers to powers. Well, we just did it. 4 times 4 is 16. 4 times 4 is 16. That's 256, I'm pretty sure. And negative times negative times negative times negative. 4 negatives make a positive. 2 times 4 is 8. And y, 4 times 5 is 20. If you want to look at that exponent sheet, you can look back at it. It'll help you out. But there's the answer. Now we can divide. So division is just subtraction. 9 over 9 is 1. It falls. 5 minus 2 is 3. So this is x to the third. And what is 3 minus 1? It's y squared. I'll work this one out just to show you. So 9x to the fifth, y to the third over 9x squared y. Those fall away. 1, 2, 3, 4, 5. 1, 2. How many are left? We got 3 of them. 1, 2, 3. 1 on the bottom. How many are left? We got 2 of them. That's how I got the answer. All right, I guess we got to reload the page again. Or restart my computer, one or the other. Beautiful. Oh, sweet. I don't know how I just did that, but I'm cool with it. And we just did dividing, right? Yeah, dividing powers. All right, let's do a mixed power one. So here's our mixed power one. We got some stuff to do. This is 9x. 4 times 2 is 8. And then 5 times 2 is 7. Feel free to practice these as much as you'd like. They'll definitely help you out. Whoa! That's what I have. Oh, because it has it's a binomial, it's adding, so you have to double it. So this is why that's not true. So if you have 2x plus y squared, you can't just do this because it's a binomial. It's 2x plus y times 2x plus y. That's why I was missing the middle term. 4x squared, that's 2xy, that's 2xy, so that's plus 4xy plus y squared. All right, let's try another one. I assumed it would just do it. It's almost exactly what I wrote. 2x to the fifth minus y to the fifth squared. So 2x to the fifth minus y to the fifth. Oh, they're both 5. Okay. 2x to the fifth minus y to the fifth. To do this, I always go double rainbow. So the first one's 4x. 5 plus 5 is 10. The last one is y and y positive. 5 plus 5 is 10. The middle is where they combine. So here we go. So that's going to be plus 2x to the fifth, y to the fifth, and the same thing. Oh, sorry, it's minus. Put them all together. 4x to the 10th, negative 4x to the fifth, y to the fifth, plus y to the 10th. And that's the answer. 2x to the fifth. Oh, sorry. 4x to the 10th. Minus 4x to the fifth, y to the y to the fifth, plus y to the 10th. So take your time with these. If these are hard for you, that's okay. You can practice some. That's every part of it. This line, those are my arrows. They worked them all out. Boom, boom. There's that one. Boom, boom. There's that one. Dun, dun. There's that one. Dun, dun. There's that one. A lot of people call it FOIL first, outer, inner, last. I always do first, last, middle, middle. I call it double rainbow. All right, let's go. We're at some algebra tiles. The expression of this. xy plus 2y. To me, that's what it looks like. Let's see if that's right. Nice. Let's do another one just for fun. This is 3x plus y squared. Nice. The tiles will be really helpful for your students if you want to help them with it. So let's go to level 2. Ooh, 2xy plus 3 plus 3 plus y. I'm going to go plus y plus 3 just for the fun of it. I like the letters before the numbers. What? Oh, because the gray is plus, the white is negative. All right. Show me another one. That one's too easy. That one's all positive. Give me a good one. There we go. I wanted a hard one. So it's a negative 2x squared minus 3y squared plus 2xy. Ta-da! Cool. So practice with those. We got a level 3. Nice. Is it really just 4x? I don't know what makes this a level 3, but let's do a new problem just to see. It's exactly the same. Okay. You don't need to do level 3. Level 2 is the same, so don't worry about it. All right, let's combine some like terms with the tiles. We don't have tiles. Well, 3x squared plus x squared, that's 4x squared. I'm just trying to show you other ways we can do this. How you're supposed to use tiles. Okay, I'll leave it. Let's do some perimeter. What do we got? Oh man, we flew through this. All right, perimeter. Okay, so what does this mean? They're telling you this is x times y. We have to know the perimeter. So this is x, that's y. So this is also x, that's also y. To walk around the shape is going to be 2x plus 2y. I know that sounds insane, but that's I'm pretty sure that's exactly what they want. So done enough math problems in my day. Yeah, let's do a harder one. X. So X. How many X's do we have here? Jesus. All right, so this is X squared. This is X squared. It's ready. Boom, 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 boom. We have 1, 2, 3, 4, 5, 6. 6X. Great problems here. All right, let's. Oh, we get to step it up. I like when you get to step it up. Y. So 6. We just did. All right. Well, maybe they'll give us a harder one. Nope. Y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. I'm going 8Y here. Try them, have fun with them, see what you can do. What? Where's the 1? Oh, if there's not a number, it's a 1. Okay, okay. Let's do a crazy one like that. Okay, so this is the same thing. So that's 1, 2, 3, 4, 5, 6. 2x, 4x, 4x plus 6. Let's see if that was right. Nice. All right, cool. Let's combine some like terms. All right. So you got 3xy's, those are friends. Minus 3y minus 5. Wow. Kyle's freaked me out, but that's okay. Let's try a level 3. These cancel. We're just left with xy. That's level 3. I will take level 3 all day. Cool. All right, so let's expression. Oh, because I'm trying to show you all the different ways to do it. So those are all the tile ways. 2x plus 1. Wait, they're minus. A negative 2x minus 1. We'll do another one just for fun. This is 2x plus 1. What? Why is that negative? Oh, because that's a plus sign and a minus sign on the mat. Ooh, okay. Let's see what we got. So this is a minus, but it's on a plus sign. So these are all the same. So this is a 2x minus y. A negative 2. No, it's a positive 2x minus y. Now let's do another one on this mat. Give me one that has one on both sides. Okay. Sorry, it's negative y minus 1. Negative 1 minus y. Oh, there's a level 2. Okay, let's get on the mat for level 2. 2 minuses. So, oh, we just have to write it. Negative 2y. Oh, because it's a double negative. So that's a positive 1, and that's a negative 1 and a negative 1, which is a positive 1. That should be a 0. Way to be tricky. All right, one more. That's easy. That's easy. Give me one on both sides. All right. This is 2x. If the negative goes up to make it a positive, so you have 2 positive x's. Cool. So have fun with these. These are interesting. All right. Let's add these binomials. You combine like terms. That's 6x plus 7. Nice. And this is with the tiles. Now we got a polynomial. 5 and a negative 1 is a 4x squared. Minus 6. And then a plus 10 and a minus 4 is minus 6. This one is called a quadratic trinomial. It has a positive x squared. It's a happy face. Quadratic. It's called quadratic because of this, and it's a trinomial. All right, let's keep on trucking. All right, we got a reload page. What? Oh, I put a minus instead of a plus. Well, that's my own fault. I think we were combining something. We did the tiles, right? We did the mats. I believe we were adding and subtracting polygons. Yes, we were. Okay, so this minus has to go to all of them. Oh, sweet. I got to write this one out because it's a little more thinking. So for when you're doing this, I would just add the opposite here. So instead of minus, we're going to make this a plus, and we're just going to change the signs. And now we're good to go. A negative 10x squared and a positive 5x squared, that's a negative 5x squared. So this is still a quadratic trinomial, but it's a frowny face because it's negative. 7x has no friends. Too bad. -1 and a -5 is a -6. -5x to the second power plus 7x minus 6. Ta-da! Okay, let's do intro to box method, and then we have 3 box method ones. So we're multiplying. Oh, I think I got to drag them. Sweet. So this is showing students the box way to multiply. I think it's really useful for students. -10. I use the double rainbow, but this thing will help out your students a lot. I've used this plenty of times when kids don't get the double rainbow or the foil or whatever it is. One error. Okay, I did it too fast. Oh, because a negative and a negative is a positive. I'll check them. A negative and a positive is a negative. Positive and a negative is a negative, and a 2 positive makes a positive. Sweet. Now we gotta write it. Start with the biggest one. The second one is -16x, and finally the last one is +6. Beautiful. All right, now we're gonna get to do it at 3 levels. I have 2 and 1, 2, 3, 4. So I'm going with 2 rows and 4 columns. Why not? Here's the 2, here's the 5. Let's drop in all of our friends. I usually like going in order from biggest to smallest, but it's okay. 2 negatives, so this is going to be a positive 6x. This is going to be a positive 12x. This is x squared, sorry. X times x is x squared. This is going to be a positive 4x to the third. And this is going to be a negative 4x to the fourth. I will make you do a level 3. Negative 50, or try level 3 if you don't want to. -30, because this one's as hard as you're probably going to have to do. And this is a -10 x squared. And finally, oops. And finally, we have a 10x to the third power. I think all those are right. Simplify. Let's start with the biggest. -4x to the fourth. The next one is the third. We have friends. That's 14. They're both positive. Next one is 2x positive. The next one is, oh, I forgot the x squareds. Sorry. -4x to the fourth. These are the 2 cubes. 12x. Oh, because this one I did wrong. That's why. So a 6x squared, and this is -4x squared. That's why it's always good to go in order. All right, let's go with the x. Does it have a friend? Yes, it does. It's a -3x. And your finally whole number, which by itself is -30. That was a lot. That was a ton of thinking right there. What? So I made a mistake. Oh, I forgot the x. I don't know when that X disappeared, but guess what? That's fine. Cool. Beautiful. All right. So I'll just look at what the third one looks like. Yeah, you're fine. You don't got to do that one as well. All right. So let's go to multiply binomials. Same idea, right, for this one. There's your 2x squared. There's your 2x. There's your negative 5x. There's your negative 5. These are your two like terms. And there's your happy quadratic trinomial. Always try to have the students say it. I always have them do the hand motions for any x squareds. The best thing to do is keep them involved. What's an easy way to keep everybody involved? Have them say what this is. Be like, what is this? What does it look like? Graph it. Tell me its roots. Tell me its axis of symmetry. There's so much stuff you can do with each one of these. Beautiful. All right, let's square some simple binomials. All right, we got x minus 9 squared. There's rules for when you have to cube binomials, but you won't have to worry about that. X minus 9 times x minus 9. I'm going to do my double rainbow. X squared minus 9x minus 9x plus 81. So it's x squared minus 18x plus 81. It's also a quadratic trinomial. Touchdown. Have them make names for the positive ones or touchdown. They usually call the negative ones suitcases because both their arms are down. But they're all good. All right, let's keep it trucking. Nice. All right, let's square a binomial. I guess it's gonna be a tougher one. Oh yeah, cool. 3x minus y to the fourth. Since it's squared, I need another 3x minus y to the fourth. These get confusing. They get kind of tough. Just take your time with it, okay? 3x times 3x, that's 9x squared. 3x times negative y to the fourth is a negative 3x y to the fourth. This one should always match it. Okay, if you're squaring something, it should always be the same. And now a y to the fourth times a y to the fourth will become a positive. Two negatives make a positive y. And what's 4 plus 4? 8. Combine your like terms, which are the middle ones. And this is, we have two different terms, so it's harder to draw. But if you have something strange, and it might seem like it's getting all weird and students don't know what to do, I think the best thing you can do is show it to them. Really show them what this polynomial looks like. Because y to the eighth is crazy, right? Y to the eighth power is no joke. So let's look at this thing. So we have 3x, right? Minus y to the fourth. This whole thing is going to be squared, and we have to set it equal to 0 to get something. There it is. Now, all of these pieces right here are wobble, wobble, wobble. It's this, the more you zoom in, the more you'll see it, but it looks just crazy, right? But that's what it is. I know it's wild, right? Sorry. We'll keep on going. We're almost done with this. Write a simplified polynomial in standard form. What is the result when this is subtracted from this? All right, so this is a good question. It takes 2 steps. First thing we have to do is square the first one. 2x minus 6 times 2x minus 6. Because when they say square, they literally want the area of a square. And that's why the box method helps so much. 4x squared minus 12x minus 12x. I never do it this way, but I'm trying to show you other ways. So it's 4x squared minus 24x plus 36. Is subtracted from. So I have 8x squared, and I have to minus this whole thing. So change the sign. That's not the change color. Change the sign. So negative, positive, negative. So this is going to be 4x squared plus 24x minus 36. I'm pretty sure that's what this touchdown's going to be. Beautiful. All right. So if C is this and D is this, find an expression of 2C plus D. So 2C plus D. So I just have to double the first one because it's just 2 times this. So that's 6m squared. It's not like squaring it, it's multiplying it by 2 plus 14m plus not 10, 20, because all three of them have to get multiplied by 2. Then I just have to add the d, which is m plus 1. I'm left with 6m squared plus 15m plus 21. If you want more help with these, just let me know. I'll show you a bunch of crazy ways where we could actually draw them. Like, wouldn't it be nice to show students, one, you can factor this. I'd factor this by taking out a 3 and become 2m squared plus 5m plus 7. Way easier to find the axis of symmetry, the line that cuts it in half, then you could just stretch it by a factor of 3. No, that's higher level algebra, but if you want to know more, I'm more than happy. I'm more than happy to show you whatever it is you'd like. Okay, let's reload the page. Here we go. Ta-da! All right, so we just did I believe it's one with the arithmetic attachments. All right, simplified by distribution 2. X minus 1 squared minus 5 times x minus 1 minus 7. This is x squared minus -1 and -1, that's -2x plus 1. Bring the whole thing with it. So minus 5x plus 5 minus 7. That was a lot that I just did in my head. So don't be afraid. Try these yourself. I just feel like this is like everything we've done before. You want to know what this is? The solutions to this? You said equal to 0. It's going to be what two numbers multiply to 6 but add to 7. So it's going to be an x minus, oh, it doesn't factor. Ah, what a shame. -6 and -1 would be a -6. So there's no way to do this. So what do I mean by I was about to, I'll write the answer first. X squared. So it doesn't like freeze out on me again. Minus 7x minus 6. What? -7 and a positive 1. Oh, I forgot the 5. Oh, give me a break. Give me a break. I was just going to show you that this thing doesn't hit the y-axis. There's x squared, but when I do minus 7x, and then I do plus 6, well, it does have 2 roots. They're just not, oh, it is 1 and 6? -6 and -1 is a -7, but why is that a -6? No, if I do minus 6, it shouldn't hit it. They should not be perfect. Yeah, they hit it, but yeah, you'd have to do the quadratic formula. I might as well just pick a hard one. Which one looks scary? I don't know. I guess they all look the same. That looks like the hardest one. So it's 2 times x squared minus 10x plus 25. So I'm just doing the first part first. So 2x squared minus 20x plus 50. And we're going to do plus 5x minus 25 minus 3. Put together what makes sense. Negative 20x and a 5x is negative 15x. 50 minus 25 is 25, minus 3, 25 minus 3 is a positive 22. There we go. 2x squared minus 15x plus 22. If you want to learn more, feel free to just reach out. I'll show you whatever mathematics that you'd like to learn. All right. And here's the ends. Express the product as a trinomial in simplest form. All right, so 2x, x plus 5/3, and 2x plus 2/3. So here's the first one, right? X and 2x, 2x squared. Here's the last one, which is 5 times 2, which is 10, 3 times 3, which is 9. The two ones in the middle, okay? So the two ones in the middle are this one, which is 10x, 10/3 x. And this one is 2/3 x, because there's just a 1 in the front. So when we're adding them all up, we get 2x squared plus 12/3 x plus 10/9. But notice 12 over 3 is really 4. Not your final answer. So 2x to the 4th, sorry, 2x squared plus 4x plus 10 divided by 9. What an interesting answer. Ta-da! Oh, they did FOIL. First, outer, inner, last. I did double rainbow, or you can use the box. Let's do a level 1. Okay. Okay, so this is going to be like 6 for my double rainbow. You might want to show your students the box for this because this is where it gets a little tricky. So it's 2x. You can break it in half. This be a way I would do it. And then I would do -1. And then I would just combine like terms because you're going to have so many terms. So it's 4x squared negative 8x. Oh, sorry, 4x to the 3rd negative 8x squared plus 2x. And then this one, since it's -1, we just changed the signs. That's all we have to do for the bottom one. So all we have to do is take the signs and flip them. Negative, positive, positive. 4x to the 3rd, cross it out, we don't need it. Minus 10x squared, cross them out, we don't need it. Plus 6x plus 1. That's what it is. When they say standard form, it just means they want it in descending order. That means the highest exponent first, then it's the second highest exponent. Then it's the one, this one is 6x to the 1. And this plus 1, you can think about it as x to the 0. So this is what they mean by descending order. 3, 2, 1, 0, and then negative if you have negative. That's what they mean by standard form. I will definitely restart my computer before I do the next one, but this is just the end of the algebra, so I thought I'd push it. Whoa! What did I miss? Did I not change the sign? But it was, oh, I put a minus here when it should have been positive. Guess I'll do it again. So it's 4x to the 3rd plus 14x squared minus 14x negative 2x squared. This is another way to do it. Negative 7x positive 7 was the only mistake I made. So our answer is 4x cubed plus 12x squared minus 21x plus 7. Ta-da. Cool. That's why I hesitated because I got one wrong. All right. We got to be close to the end for this guy. We did multiply polynomials level 1. Now we're doing a polynomial divided by a monomial. Doesn't matter. Oh, I hit new problem by accident. You just have to Lotus flower it. It's nothing crazy. So 25, you just do this one first. So this is 5s, and what is 4 minus 1? 3. And then negative 10 to 5 is negative 2. 3 minus 1 is 2, 2s squared. So your final answer is 5s to the third. The other way, you just have to write it up and down, or you do it any way you want. 2s squared. Here's 3 properties of numbers. Cool. Let's do some properties, remember them. Okay, the expression was rewritten using distribution property. 9 times 3 plus 1 equals 9 times 9, which equals what? 81. And 9 plus times 3 is 27. And 9 times 6 is 54, which also equals 81. Yay! We did the property. Oh, I guess it's flooding. Yeah, rain's been crazy here. All right, so let's do another one. So you can see another property. When you move this is called associative. You're just moving it because it's associative property. And I would do some of these, okay? This stuff is really useful. So 3 times 8 is 24. And 24 times 2 is 48. 8 times 2 is 16. And 3 times 16 is 48. That's the associative property. Let's do one more property. This is commutative because it goes backwards. Commutative property of multiplication. So 2 times 4 means, I don't know, 8. This is 8. Oh, I guess this would mean this is 4 plus 4. And this is 2 plus 2 plus 2 plus 2. Yay. Cool. So do the other identities yourself if you want to. They're good. Line 1 to line 2, that was distributive property. And x, y, yx. And, oh, this is commutative because it goes backwards of multiplication. So definitely practice with your properties. It's really good to show your students what they are. You get to identify some properties. We subtracted 4 from both sides. So that is subtraction property of equality. It's got to be hard. Oh, yeah, there's a harder one. What did we do? What did we do? 3's gone. Oh, we did the subtraction property. All right. We did this already. One step inequalities. I'm sure we have them here. I guess we didn't. All right. This is going to be just minus 5. So x is greater than or equal to 5. So I have the 5, and it's going this way, and it's the whole number. Nice. M is negative 10. A negative 10. So 10 minus 8, nope. 10 minus 8, nope. Negative 10 minus 8, nope. It's got to be this first one. I like how it's the last one I tried. All right. So Jordan needs to order some supplies for restaurants. The restaurant he works has 370 forks. There's currently 90 forks. Each is on sale, contains 18 forks. We definitely did this one already. You don't have to do this one again. Yeah, we did these already. So I'm not going to make you redo the ones you already did. Spend 780 bicycle store for some new gear and biking outfits. Assume all prices listed include tax. Write and solve the inequality which can be used to represent X. Number of outfits while staying within our budget. So we know it's got to be like this, 780 at the end. So we can't go over budget. It's at most 780. So the new bicycle is 424.72. 3 reflectors, 3 times 12.54 plus 21.92. I need more space. So we have 3 times 15.54 plus 21.92 plus 424.72. What else do we have? And this is plus X 49.29. All has to be less than equal to 780. What a crazy, crazy, crazy problem. So here it is. 3 15.54 plus 21.92 plus 424.72 plus 49.29x is less than or equal to 780, and we got to solve this thing. So just do some multiplying. 3 times 15.54 plus 21.92 plus 424.72. What an expensive bike. All right, so we spent 493.24 plus 49.29x is less than or equal to 780. So we have to subtract this from the total. So I'm just going to do minus 780, and just the answer will be negative. That's the beauty about subtraction. And then all I have to do is take this number and divide it by 42.29 to see how many outfits I can buy. 6.8. It's going to be what? Less than or equal to, last time we know what she can only buy 6 outfits, right? But because it's a computer can't understand, so we're just going to put 6.78, which I don't like, right? How many outfits can she buy? I would just say 6 outfits. She can't buy any more than 6 because she can't buy 75% of an action. It is 6. Oh, great job. I love it. I love it. So they did actually do it the right way on this one, which makes me feel really happy. Cool. So I got 6, they got 6. Now, that was a lot of work, I know, and I know I should probably stop, but I just want to show you one more thing. Because I think this is so helpful, and it's the last one. So I'm going to show you one of these systems of inequalities. I think it's probably one of the most helpful things you can see. All right, so let me download this, and let me just do, I don't care. I'll just do one of the ones. Because I know it has the answers, but I just want to show you these. Let's do numbers. We'll do number 2. Let's do number 3, and we'll do number 4 because they're right next to each other. So let's draw the first one. So here's your first inequality. All right, so it's going to be positive 2. And we're going to go up 1 over 2, up 1 over 2, down 1 back 2, down 1 back 2. All right, and it has this, so this means this is going to be a solid line. There's your solid line, and I'm going to highlight red. Cool. So, because, oh, sorry, I'm a big liar. Can I undo this? I can erase it, though. You see how we're less than? We're less than, so I want everything under the 1. Cool. Beautiful. All right, so that's the first one. All right, let's do the next one. Let's do the next one in blue. Okay, nice dark blue. So now we're at -3. And I'm going to go down 2, back 1, up 2, back 1. Notice that I'm right on my slope because of what it's doing. Now, do you see how this one is going to be hashed? So we don't actually touch it. It just approaches the line. Now we want everything less than this. So if I want everything less than this, I have to highlight in blue everything below this thing. So where's the answer? Well, the answer is the purple. This is your answer. Whatever doubles. That's some not dark enough. So we just want the double. I guess I can do more thickness, right? Well, it doesn't really let me double it, but that's where your answer is. Your answer is just between the two. It has to be below this line and under this line. So that's the answer. Now let's do one more. Let's start with the red. So we don't have anything except we know that x is less than -3. What can y be? Whatever we want. So we know it could be -3, 0, -3, 1, -3, 2. It's a vertical line and it's solid. And we want everything to the left of -3. Notice you could get a not an answer, right? Sorry. All right, and now we want everything under this line. So I'll do the other line in blue. So here's 2. I hope the rain isn't too loud. I'm gonna go up 5. Well, I can't go up 5 and over 3, but I can go down 5, 1, 2, 3, 4, 5, and forward back 3, 1, 2, 3. So here it is. And this is our dotted line. We want everything what? Below this. So if I want everything below this line, this is why color pencils happen. So I want everything below this line and everything to the left of this line. My answer, I'll just draw it, is right here. I always give students 3 colors when they're doing this, the answers here. So let's check 3 and 4, make sure we did them right. 3 is there, 4 is there, 3 is there, 4 is there. Beautiful. Beautiful. They look great. So I would suggest trying these just for yourself. And guess what? This was the end of algebra. I hope you're excited for probability and data. I'm going to do all the geometry ones next, but feel free to reach out to me if you have questions. And I hope this was useful, and good luck on the test for it.